Good morning here. My name is Justin. I'm a physiotherapist here in the CBI Marshall Clinic here, and today we're doing a pain talk. Now, this is the first part in a two-part series, about 40 minutes long. Normally it's kind of like an interactive, a little bit more dialogue between people. But today here, I'm just going to get the nitty-gritty, the details. This is a very condensed talk here, kind of put together from a number of different courses, kind of all smashed into a very tight, dense component for you. And so if you want to be taking notes while you're doing this here, maybe that's a good idea. And of course, if you have any questions, you can just email me itself. All right, let's begin. Pain. What a question here we want to be answering here and trying to get the underlying understanding of what's happening. We understand that the more we have knowledge about pain, the better we can treat it, of course. And what's more knowledge in the 21st century? And yet, it seems to be pain is still a big problem here in our world. In fact, it's a big problem. 1 in 4 Canadians, 1 in 4, are actually working and suffering, dealing with persistent pain, pain that has not gone away yet, of which they have not yet found the cure for. So we want to understand, why is that the case here? And is there something that we can do? Well, there's new leading research here that indicates, yes, there's something that we can do here. I'm excited to share this with you. And this is why we're talking about it today. All right, let's begin. There are 2 types of injuries in the world, only 2. You probably know what they are. The first one here looks like this. It's called the bump in the road injury. Maybe you scratch your arm, maybe you cut something, maybe even break a bone. There's a course of a pain that increases and decreases as it heals, and you continue on with your life. Nothing really changes. The bump in the road injury happens to all of us here. That's what we call acute pain. This is not the focus of our talk here today, because this largely resolves in and of itself here with maybe the medical intervention that we have here around. What I'm more interested in is the second type of injury that we have. And this one here is called the fork in the road injury. The fork in the road injury can also be defined here as persistent pain or chronic pain. Something that has happened here, it credited an event of some sort into the body, most likely, and you're not really left the same afterwards. Something's changed here with the pain system, something's changed here with the body, and it's not going to be the same afterwards. We know here that persistent pain or chronic pain will occur here for many individuals. We said 1/4, and it's kind of defined here as pain that lasts longer than 3 months. But we know now that it doesn't have to take 3 months to actually fall into this category of a fork in the road injury. So I'm very interested in this part. We have 3 main tenets here we want to start as our first points about understanding the fork in the road injury. Number 1, pain is in the brain. Now, this is not probably new news to you here. You've probably heard this in a lot of the different variations. But what do I mean by pain in the brain? Well, if you didn't have a brain, you wouldn't have pain. You don't really perceive things when this is not attached. Same thing is that we don't actually perceive things when this part isn't attached. But pain in the brain here just means that we perceive and explore our entire world with this piece of neural mass between our ears. And it's pretty phenomenal here of how it does that, the supercomputer that's involved with that. And we'll get into more details about that on the second pain talk. Point number 2. Pain is not an accurate representation of tissue health. Pain is not an accurate representation of tissue health. What do I mean by that? Well, you've probably seen that before. Maybe you even have experienced it before. You're walking down the hallway and you bump your shoulder on the nearest door, and you didn't really notice it. And maybe the day later, you kind of look at your arm and you're like, whoa, there's like a big bruise there. Like, I'm not sure what I did. This is the idea here is like tissue health. Like a bruise here is an opening of blood vessels. It's a leaking of chemical fluid on the inside. It's damaged cellular material. infiltrating all the nerves underneath the skin. And yet we didn't even register it. It seems quite remarkable. But then there's other examples here where pain is not accurately defined here. And this is more acutely noticed here when you see people going into the hospital, and particularly the ER department. It doesn't explain everybody, but just hear me out. Somebody walks in, they have a broken arm. And then somebody asks them with the little clipboard here, what is your pain today? How are you doing? And that person with the broken arm says, well, you know, it hurts. As long as I don't move it here, it's kind of at a 4 out of 10. The next person comes through the ER here. They have a hangnail in their toe. And they're limping along and they're quite distressed about this. And you ask them on the clipboard here, what's your pain here today? And they say 9 out of 10. This is really bad. It's bad enough that I need to get to the emergency right now. See, the amount of damage here doesn't really predict how much pain they're in. It's more about the context of the person, as we'll talk about a little later. There's an interesting example along here, this emergency department here, where a person walks in and a hammer was stuck in through their neck. Someone had thrown the hammer and the forks of it had gone right into the neck, and he's holding the hammer as he's walking into the emergency department. And that same person asks them with the clipboard, what's your pain at today? He says, nothing. It doesn't hurt a bit. Not unless I wiggle the hammer like this. So he sits down on his chair and he waits in line here for him to be treated. His friends are there, pale-faced, guilty looking beside him. And you start making jokes around about different things. And he starts walking around the clinic and he goes, dun, 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 dun. Hey guys, guess what I am? Hammerhead. Ha! He bumps his knee in the waiting room, and all of a sudden he yells, whoa, my knee, my knee, my knee. He's holding his knee and the hammer at the same time. And all the nurses and the doctors at this time are now rushed to him because he's making a lot of noise. And he says, don't worry about the hammer. It's my knee that hurts. That's all they heard from that story, because he's whisked off into the inside of the ER where they treat what? This thing. So it can be confusing here, and it's complex. It's not simple. One story doesn't mean all. It doesn't actually reflect here many people's opinions or experiences of pain here. We have to trust beyond this one here that pain is not an accurate representation of the tissue health itself. Number 3. Pain is more like a protector. Protector. This is more defined here as we go into an example, and I'll show it to you here on the whiteboard here. What do I mean by pain as a protector? Well, here's a drawing, a graph about the level of movement in a finger. So the bottom here is there's no movement in the finger. And the top here is there's so much movement in the finger that you get to tissue tolerance. Tissue tolerance. This is what I mean. So I have my finger here. And as I pull it back from zero movement, okay, I pull it back a little bit, I'm going to experience a little bit of soreness in my finger. So there's a little level there. There's my soreness. After soreness, if I continue to push it back a little bit further, I might actually feel pain. And there's our protect by pain line. Protect by pain. If I go further than that one, I'm going to get into a flare-up. And if I go past my flare-up, I'm eventually going to get to the limits of tissue tolerance within my finger. So we see here, our pain will come before damage. It's designed here to actually protect us from damaging it. And this is kind of the example of a normal system, an acute injury, as it were. But we're not talking about here acute injuries. We're not talking about the bump in the road injuries. We're talking about the fork in the road injuries. And there's something different about those ones. It's actually enough of a driving power here to actually change the pain system itself, change the sensitivity, or change the way the body responds to those sorts of injuries. So it's a little while later here, and the finger has been injured. And we know that the graph here looks a little different. Here, for one, it's a little bit shorter because the tissue tolerance, because the finger's been injured, it doesn't actually move as far anymore. Things have changed. Maybe there's scar tissue in there. Maybe there's some sort of different healing process, just maybe not as flexible as it used to be. But this time, it's been persistent for a long time. And when you move it just a little bit back, the pain starts. The pain starts really early. Just before that, it's sore, small little wiggles. Just after that here, it gets flared up. And there's where we live. There's the soreness line. There's the flare up line. Same graph. There's a difference now. One is more sensitive than the other. In fact, we now know that it doesn't actually even take that much to initiate pain sometimes. That even thoughts and feelings can initiate pain. This driving force down here is kind of dictated by two different pathways itself. And I'll explain those a little bit here in my next graph. The first graph here is a kind of a pattern of movement that we have. And it might look like something like this. You have an injury here, and so you're moving through the injury. It's been a little bit of time, maybe a number of weeks, and it's time to really push it. So you decide that you're going to go to the gym and you do a long walk on the treadmill. And then notice that, oh, I did too much of that walk. Takes a little bit of time to recover from that one, but you're strong-minded, so you're going to go again. And this time you're going to go a little longer or harder at the gym, but you find out that you crash right after it. And every time that you push it really hard, there's an equal and opposite reaction to that one, which is a rebounding effect. And this is called the boom and bust cycle. Boom and bust cycle. What it can tend to do here is actually create a greater sensitivity, push the protect by pain line to an earlier state. The second one here is where you have an injury, and you decide to rest for an appropriate amount of time. And then when it's time to initiate movement again, you try and you find, well, there's pain actually when I move. So you're just going to do a little bit less. Maybe you walk a little less. Instead of walking the 1 kilometer, you're just going to walk a half a kilometer. Next time you try out walking half a kilometer, that still causes pain. So you walk maybe 250 meters and that causes pain too. So you walk a little less and a little bit less and a little bit less. And of course, the less you do, the less it takes to initiate the pain cycle. This is called the avoidance behavior model. Boom and bust and avoidance behavior model. Now, I want to propose that there's a different way here to do these sorts of rehabilitation here. And you've probably already guessed it. The way actually to get moving forward here is a little bit more steady. Maybe start in an area here, you know that you're okay. You take a step up, you know that you're okay, and you challenge yourself a little bit by a little bit, week by week. But progress here doesn't always look like a step ladder. Sometimes it can look like a little bit of a curlicue and then an up and down and down. We know that we're kind of in the right trajectory here when things start to change a little bit for us. We have better control of our movements. And we might even notice here that this will start to change back to its original state, perhaps just a little bit. And this is the idea here of the rehabilitation that we're talking about here, is how do we change pain? Let me give you an answer is that you actually have to change the nervous system. This is what we'll talk about in the second part of the whiteboard. Now, if you guys are listening at home here, it's been about 15 minutes of listening. It's time to take a bit of a break, grab a drink of water, put pause in the video, and we'll get going on the second part of the whiteboard. Lucky me, I have a whole nother whiteboard to use. Now, this portion, we're going to be talking here about the neurophysiology of pain itself. So you've always wanted to know that. You've always wanted to take a neurophys class. Oh, I'm excited to share with you what's happening on the inside of the body itself, right? Well, the inside of the body, there are nerves. And nerves, they look like this. They have little tentacle feet, and they can feel things. They can feel all sorts of things. For example, they can feel like touch, hot and cold, pressure, vibration, sharp or dull, chemical signatures. And so they feel all those sorts of sensations. And when they get a sensation like that, that activates a nerve ending, it transmits an electrical signal here to the spinal cord. This is kind of what that looks like. It's got this conduit, moves along, then eventually ends in a big ball mass at the end, which reaches here another nerve on this side, which picks it up and goes towards the, guessed it, the brain. And this is where pain is registered as pain. That's why we say pain's in the brain. But I'm really interested in here what's happening down below a little bit. There's nerve number 1, and here's nerve number 2. This one's in the body. Let's say my joint, maybe my muscle, maybe the skin, maybe the tendon or ligaments. And this one's in the spinal cord here, picking up and sending the reflex, the signal here to the brain. When this is propagated here, so we get something that's too hot or too much touch here, it's a signal at this point. That's what we call it. Regardless of what it is, it sends a signal going down, electrical signal transmits to a chemical signature. And this is a neurotransmitter. We'll just draw them as little dots. And they're kind of released into the atmosphere between nerve 1 and nerve number 2. These little dots, these neurotransmitters, are released into this area. For them to be picked up by nerve number 2, you need kind of like an antenna or a receptor of some sort. So we draw these little Ys as a receptor. If the chemical signature here will touch, receive on the receptor, well then, that propagates a signal. And of course, that signal goes up towards the brain. Very wonderfully made. This is really cool stuff. Some kind of mechanical stimulus turns into electricity, turns into chemical, turns back into electricity, and back up. This is traveling so fast, you wouldn't believe it. The chemical signature of electricity moving through is traveling at 250 miles per hour. Instantaneous. This is why when we step on a rock, we know exactly where it was, and we point to it immediately. We know where it is. We don't have to think about it. It is automatic with this one. It is so fast. And we knew this for a long time. Many decades, we kind of knew that the nerves 1 and nerve number 2 are kind of involved. And we thought we kind of knew everything about pain. That makes sense. Pain's over here, transmits to the brain. There's some new information that's come out last 2 decades about that there's something else that's also governing this process, which is why I'm excited to share with you. Gets a little bit detailed here. Hang in there. It includes this guy here, the green glial cell. The glial cell is part of your immune system. Like your immune system here that is able to raise your temperature of your body, give you a fever, fight off infection, create more blood. those sorts of things. We have these glial cells, and for every single nerve that we have, there's 2 to 3 glial cells involved with it. They help facilitate, they kind of regulate the environment, oversee what's going on, making sure the nerve is kind of acting in appropriate behavior itself. The glial cell has the ability here to do a few different interesting things. One is it puts a negative sign here on nerve number 2, the spinal cord. It can kind of put a damper onto it. It's calm. This is kind of, you see this maybe quite often. Kids are playing with their friends at the playground, and they're really involved in this game of tag, and the kid biffs it. Boof. Skins their knees. Gets up, keeps running, doesn't even notice. You're like, whoa, that's amazing. Like, how did he do that? He just suppressed a lot of pain. Well, he didn't think about doing this. There's probably more things involved with the game of tag. But the glial cell has a large role to play in that, and it puts a negative on it and says it's actually not the time to really pay attention to the skin knees. The immune system has a part to play in this, and it can actually dampen the signal here. We used to call it the pain gate, but I won't use that term extensively here. Just kind of puts a little damper on it. But if you can put a damper on something, what can you also do? You can raise it up as well. So the glial cell is able to increase that signal, put a megaphone on it, and if it does that here, puts a little plus signal, thinks it's actually more important. Hey, this thing is really important. Maybe you've been there before, maybe you remember it from a previous injury. Maybe it's just so constantly inputting. It says this is the time to increase it. What it'll do here is it'll grow more receptors. We'll call them flowers. Maybe it'll grow like twice as many. Maybe it'll grow 5 times as many. Either way, whenever there's more receptors, there's more propagation of signal. And now the spinal cord here has a lot more of a signal here to transmit to the brain. The brain has to interpret what's going on. That's a louder signal. The other thing that the glial cell can do here, given time, remember, not early injuries, longer injuries, it takes a little bit of time, 6 weeks, 8 weeks, 12 weeks, blah, blah, blah. It starts to grow new nerve endings. Yeah, nerves can grow. Neurogenesis, and it will grow and it'll become more sensitive to that area. Is also put a plus on this one. Now it has more feelers in that area. Makes sense with a previous injury you've had. Maybe you notice that previous injury sometimes acts up later on in life. Maybe there's new nerves that have grown there. And so we like to describe this as is a bit of a different system. This is called the protectometer. And the protectometer, like the scale from 1 to 10, dictates here how sensitive the system is. Some days you've had good sleep, things going well in the world. The protectometer is a nice humdrumming along at 2. Things are okay. Glial cells not too overactive here. And all of his little buddies, the 2 or 3 other glial cells for every nerve, are also kind of at a nice, chill, relaxed state. There's also times here when the protectometer can really go up, really high. Bacterial infections can do this, loss of sleep, maybe stress. And lots of other things here can really make the protectometer go quite high on the cell. So we want to have an understanding of what do we do about this? How do we change these things, protectometer? I want to challenge you here for a few things on this one. And I'm going to challenge you here with a few questions that you want to be asking yourself. Hard questions, maybe things you haven't thought about before. Number 1, how do I know I'm safe? Like, how do I know I'm safe to move? Like number 1 question, people come to me for physio. Am I safe to move? Is this safe to do this? Is this normal? It's a great question that you should have for yourself. It's hard to answer. Sometimes it means that you have to explore new movements that you haven't done before, challenging yourself. Maybe it's other times you want to be talking with your team, physiotherapist, a doctor, chiropractor, etc. You want to really understand your own body. Does it feel safe? And if it doesn't feel safe, do I know it's safe? Remember, safety here is kind of like that finger example, where I know that I'm not going to do damage to my finger because I have an early protective system. See, another way you can rephrase that is how do I know I'm not going to damage myself? How can I trust my body to be resilient in this regard? Question number 2. How do I know if I have an overprotective nervous system? Over. How do I know if this protectometer is the one that's really overprotective? Like we have a protective nervous system and an overprotective nervous system, like an alarm bell that's going off on early signals here. And some things you might notice here if you have an overly protective nervous system here is that the protectometer goes high often. It can come on here through smaller things, such as innocuous stimulus, noise, light, touch, those sorts of things. Stress has a larger impact here on an overly protective nervous system, sleep as well. And maybe here it's just the memory of it here itself. It just keeps on cropping up and up and up. We'll talk about how to deal with that in the second talk here. But number 3, this is the one I want to focus on for our last bit. How can I retrain this thing? I know that I'm safe to move, but it still hurts. Yeah. I know how maybe my protective system here is revving on high engines here. How do I retrain it here so this doesn't become as sensitive? I can reverse these things. The reason why I show you this stuff, the neurophysiology of the body, is that this stuff is reversible. It's amazing. Actually, the studies would show here that those little receptors themselves grow and die every 3 days. Every 3 days, you kind of have a new opportunity to retrain your nervous system again. But the way we treat our pain does dictate here if it's going into the more sensitive trajectory, more protective trajectory, or more safe, more in control. And so I'll give you the A, B's, and C's here of how to retrain your nervous system here. Quick succession. And then we'll end here our lecture. Number A, letter A. You ask yourself these questions here before you do a movement. As you said here, safe. Am I safe to move? Am I safe to go for a small walk? Am I safe to do that stretch? I have pain when I do it, but is it safe to do? Again, here to know here what is safe here does take a little bit of experimentation, absolutely here. Maybe trust with your body a little bit. Maybe moving forward here, something you haven't done before, trying it out. But definitely something that's safe here is going to be into a movement category for yourself. Pay for it later. If I do something that's safe, that's fine. I can lift that much once. But if you say to yourself here, I'm going to pay for it later, or it's going to cost me, well, then I would recommend you don't do that. It's not very smart to do things that you know that you're already going to pay for it later or regret. So if you have pain and it's not safe, don't do it. But it is safe, keep going. If you're going to pay for it later, don't do it. But if you know that you're not going to pay for it later, it was worth it, Well, then you can go on to letter C. And this is the breathing category. Breathe. Calm, slow breaths, gentle in and out. Even if it's painful, if you know it's safe, you're not going to regret it later, you are allowed to breathe through it. On our next session here, we're going to talk a little bit more about that breathing pattern here, how to retrain the nervous system, again, revisit a little bit of this neurophysiology, but we're really going to focus here on this thing, the pain in the brain. What that means here, kind of do a dissection of it. And for you to prepare for that one here, I'd ask you to write down one thing. Write down the one thing here for me is, what is the difference between a threat? What is the difference between a challenge? So you can write those two things out there. You can put a little list. What is the difference between a threat and a challenge? And we're going to pick it up there on the next time. Thank you for listening to me here today. My name is Justin, physiotherapist here at Marshall. We'll see you guys next time. Take care.